Hello, everyone. My name is Reza Habibi. I am a computational media PhD student at UC Santa Cruz, and today I'm presenting Empathetic AI for empowering resilience in games by helping great co-authors, Johannes, Jonathan, and Maggie, which are here. So let's just start with something like this. Do you remember the last time you smashed your computer? Or you have one example here. So it's happening sometimes, not all the times, and don't try it at home. But usually people have different emotional responses after a failure or difficult time in the game. But what are those patterns? Based on literature, people emerge similar patterns. Like according to the literature, people usually do situation assessment, reassess, and actually replan their strategies. And other people call this type of reassessment emotion regulation. It means that you figure it out, you have a problem, you have a difficulty in game, and try to change that and regulate your emotion. Also, there are lots of advantages around emotion regulation. First of all, it actually impact on higher cognitive flexibility, which means that it can improve your performance, specifically for a job, for a task like playing a game. And also it can help to, improve your coping and in general mental health. There are different systems out there to help you regulate your emotion, like Intelligent Tutoring system, ITS, which is one of the examples that help people to regulate their emotion. But let's get back to the fundamentals a little bit and see why we care about emotion, what's the connection with AI, and why we are doing this. First of all, there is a field for affective computing, which a subset of artificial intelligence that measure, understand, assimilates, and reacts to the human emotions. And why we care about emotion and AI, because there is always an interaction between a human and a game or a social media, and all of these interactions actually really important to us to see in order to understand those interactions between the human and those medias. But the question is, how do humans understand emotions? When you look at to someone, you look at their face, their hands, their gestures, you can see whether they're angry, sad, or they do something like this, right? But how machine can understand this? So machines are really good to analyze large data. However, they need a data which is ecological valid. It means that it can demonstrate a real world phenomena like emotion. And of course, games are one of the best or most powerful tools for studying human interaction between human and machine. And ARGs, or alternate reality games, is one of those examples. ARGs are games that actually put you in a fictional narrative that unfold through interactions, which are real world applications. So in order to understand emotions, we made an ARG, which is called Lux. Okay, this is our ARG that we made. So there are two components in this. There is an AR app, and there is a Discord. Participants receive their puzzles over the Discord. They're supposed to walk around the campus, use the app, scan the physical markers, get some clues, and use those clues to solve the puzzles and gain scores and progress throughout the game. But we use this type of ARG to collect the data we want and to propose the average and to answer our questions. So we asked these questions of how to develop a game AI system tools that aid players in emotional regulation. And we use these 4 steps to answer the question. First, we focus on the emotion after failure in the game. And we discuss the importance of player resilience and emotion regulation and how ITS can help us with that. And we introduce a 6-phase data-driven approach using collected data from the Lux ARG method. The first phase in our approach is to, of course, collecting data, and you need to clean the data, pre-process it, and after that, you need to divide the data into episodes based on their tropical and temporal affinity. Like example we have here with the user ID, the text that they have, and their stage of the game. And the second, of course, the second stage is sentiment analysis. And it means that you need to go through the text you collected throughout the game, and of course, develop a label scheme based on their emotion balance and the emotions that emerge after the failure and challenges. This is an example of the second one is here's an example of how we label those data, like user ID, the pain point, which is a challenge or failure in the game, and the emotion they emerge. We also ran through interreliability rate, which is a higher rate, which means that all the researchers, when they're labeling the data independently, they can receive a higher accuracy taken together. Here's also another example. Here's an example of phase 2 that you can see. This table actually showing you how is a label schemes we develop, like we have a pain point in the game, failure, conflict, and challenges. Of course, these are two emotions that we talk about and we focus on. And of course, we have getting puzzled state and success. We use this labels scheme to label our data. The third phase is making a dependency graph. So what that means and what is helpful, because it tells us the interaction between the users throughout the game. Like at the beginning, they received the puzzle, what user 1 did, what user 2 did, and all the procedure until they success or fail throughout the game. And of course, in phase 4, we went through emotion regulation identification. There are lots of literature around this in psychology. And in general, we use one of the famous one, which is Gross taxonomy, to define models, emotion regulation models. And we use the cycle, like, first of all, players alternate their strategies, they implement it, and they monitor whether they succeed. We follow these cycles throughout the data we had, throughout the dependency graph we got, and we found 3 distinct strategies in our game. Or for this specific player. The first one, which was very interesting, was player 1 started the game and they went through a failure. And after that, we found that, for example, here, user 2 transferred from positive emotion to a neutral state after the failure. Another example was they received user 1 here start with a positive emotion. They went through another challenge with user 2 and they failed. And after that, you can see emerge of negative emotion from the users. And after that, user 1 just gave up. And here's also another strategy that we call encouragement. User 2 and user 3 work together in order to solve the puzzle, and finally they did it successfully. And you can see the emerge of positive emotion after the success of this puzzle. Of course, when you get all of those identification, those strategies throughout the game, you need to go at learning these things. So there are lots of approaches to learn all of these patterns. So we propose our phase 5 to using different concepts like attention-based bidirectional short-term memory, or semi-supervised learning, or graph agreement models to learn these type of patterns throughout the game, since you can collect lots of them throughout the ARG and make a model of their emotion regulation. And finally, in phase 6, we propose to create our agent, EAI, who actually use the model throughout the live communication session. It can detect all the emotion regulation or all the players' emotion, and of course intervene and help them to regulate their emotion. There are some limitations. For example, of course, we have different phases, and for each phases we have biases in each of these phases we should need to address. And this is not this project presentation, and of course it's applicable to other AI approach. Of course, sample size should be large, and it could be challenging for some games, but here in EARG, we're trying to scale up our data. And of course, we need to bring individual differences, because individual very important to individual differences, very important to understand people emotion. And of course, we implemented some of these phases, but we can implement it and using AI and do all of this automatically. Okay, thank you.